There will be a link at the end of the session where you could download the slides. And given it's AWS, so I've uploaded it to an S3 bucket, and it is a time-limited kind of a URL that will expire after some time, right? So with that, let's get started, right? So my coordinates are here, so you could connect with me on LinkedIn or on Twitter. So this is personal plus professional, and this is only professional. So you can, whatever your mileage is, you can definitely do it. Let me try to keep that camera on, so that at least you can see, where me and things like that. If there are some bandwidth issues, I will switch off the camera, as when things happen, right? So brace yourself, because we're going to go and cover a lot of stuff. But my, the agenda here is primarily to explain to you the various options that are available in AWS so that you make an informed choice, right? I think we present the information, as you know, with AWS. There's always different ways, right? I keep telling when I speak to my customers there, we give you a lot of choices, like multiple ways to cook a biryani, right? I mean, it's up to you to how you want to do it, right? So based on your use case and cost reasons and things like that. So this is some stuff that I want to kind of cover, give you some background about some of the services. Some are workhorse kind of container orchestration platforms, but you'll be surprised a lot of things that have happened, new features that keep happening even with ECS or EKS, and a couple of new services, Proton and App Runner, which I'll cover, and App Mesh, which is not so widely known. I just want to kind of give you a glimpse on what it can achieve. And then, of course, the most important question, I think, between all this, how do you kind of decide what to use, right? And then a few modernization tools, and then finally, some links and things like that. Hopefully, we have around 1.5 hours. So that's why I meant brace yourself, right? So let's go on, right? So, I mean, the first question is, obviously, I think this talk is more tailored around containers, but there are obviously different ways to do, modernize your application, right? So you could very well use other services too, but I'll kind of skew this towards containers because that itself is a very vast topic. But always ask the first question is, why containers? Okay, so it's not that, when somebody runs stuff, you don't have other choices. Like, for example, you could very well run them on VMs or, even Lambda, right? But I mean, the two, I think the biggest reasons happen to be that you can innovate faster. I mean, it's not a buzzword. It's definitely the agility, the pace of, releases and, things that come with, innovate faster is truly higher with containers, okay? Because it gives you a very, very, I would say a low latency way to, release things, okay? And similarly, to innovate better, right? So you can, by running stuff on containers, you can integrate with a whole lot of more things by having a lot of other plumbing that comes with the containers. You could take a lot of risk-prone approach, right? Without because there are a lot of safety features that you have with containers, which will enable you to innovate better. Okay, we'll come to that, right? But it always asks a question, right? So why containers? It should not be that because it look good on your resume or things like that. Of course, it might, but ultimately somebody's going to ask you, why you're spending this, why you took so much, some time to kind of running that was probably running very well on a VM to containers, right? So always ask that. And one thing that I've not mentioned is there's also a lot of efficiency you get with, especially related to costs and things like that. So that's also very important. You got to measure and things like that. So I will not be monitoring the chat too much, but I just saw how will the recording be shared. We'll do it via user group leads, Dijish and Saurav. So they will probably upload that somewhere and share the link with you. Okay. So now, coming to a very high level, ECS is our AWS native kind of, container service. It's been there for some time. Okay, so it's been, I think, more than 6+ years, since ECS came into the picture. And we have innovated that quite a lot, which will come to that shortly. And then, of course, we introduced Fargate, which is a serverless way of running containers, right? And then, of course, the new thing that happened this year with ECS is this concept of ECS Anywhere, which I'll be covering, where you could run essentially the ECS tasks or containers on some of your servers that might be in your data center, right? So you will need connectivity back to the control plane here, but the ECS Anywhere is kind of opening up our doors for some workloads which might not have been possible earlier. Okay, we'll go into some detail on what's possible here and things like that. Okay, and then of course EKS was released a couple of years back, a managed Kubernetes service. Then we, of course, the other thing that will happen this year, not yet happened, is this. Similar to ECS Anywhere, we have EKS Anywhere. It's very important, I think, when we look at the architectures, is ECS Anywhere and EKS Anywhere are very different. Okay, in the sense here, the control plane will still run on AWS. In EKS Anywhere, it's currently in a private preview for a few customers. I think there is a link if you Google it where you could ask for a request for a preview, but it will be generally available sometime the later part of this year in 2021. But the architecture is different. Okay, so here the control plane will still remain on AWS, but here it will be a complete EKS control plane plus data plane that will be running in a data center. Only the management and monitoring will be happening for the AWS cloud. And then, of course, we also released another thing this year, which is a managed OpenShift in collaboration with Red Hat. I don't have too much information on this call today, but in the choice that I do have a slide where how when do you have to look at the ROSA and things like that, right? So this is at a high level our picture, right, in terms of the services that we have, right? Now let's go a bit deeper, right, into ECS. This year, as you know, and since last year, we had the pandemic. I hope you and your families are doing okay. I think looks like, I think it's kind of tapering down, but you never know with third wave, fourth wave, and so on and so forth, right? So just be, I think, careful out there. But we have had, as I said, ECS has been there for some time. We have some large customers that are running ECS. I'm not going to go into detail about each of these case studies, but we have some larger customers. I mean, all three are very large in terms of scale. Okay, whether it's Moderna or Instacart, pretty popular in the US, right? It's like I guess kind of a Dunzo for groceries and things like that, right? So, and then of course Disney, these are big customers for ECS. And closer home, ECS actually powers a lot of AWS services within our family of services. Okay, so things like SageMaker, Lex, Poly, and Batch, they all use ECS internally. And in fact, our .com, Amazon.com recommendation engine is actually behind the scenes. It's actually powered by ECS, right? So these are all. At least this entity itself has, you should imagine the kind of traffic it kind of can get hit, right? So this is, I think, one misconception I have when I talk to customers is, is it a real thing? Is it still being used? Do you have larger customers still using it and things like that? Yeah, absolutely yes. I mean, I sometimes tell, I have two daughters, right? We love both of them equally well. ECS and EKS, we have large engineering teams, very intense roadmap that keeps innovating, and we release newer features and things like that. So absolutely. Now, of course, bunch of snapshot of customers both in India and across the world who use ECS, right? The first key thing here is, why do customers choose ECS? It's primarily, I think the biggest thing is it's well integrated. It's a native AWS service. So, for example, I was doing a workshop with a customer yesterday. They are very new to containers, okay? And in fact, so when they started using ECS, we were able to take a sample application and look at how you could containerize it. everything, via the console, using, if you want to attach a load balancer to it, integrate CloudWatch and few other things was pretty native. I mean, so in the sense that you could use just the console itself to do everything for you. If you're not, now of course, you got a fully managed control plane, it's enterprise grade, and then you have a choice of whether you want to run it in server or serverless and few other things, right? And a lot of things. So it's kind of, I guess, well integrated with the AWS ecosystem. So that is, I think, one of the primary reasons. We'll go a bit more deeper in we select, more questions about why we ECS and things like that, right? Now, on some of the basic things with ECS, right? It's important you need to understand the jargon, right? So before you do that, the first key thing here is just running stuff on containers is not going to help you. Okay, so you might run some stuff on containers, but you are not going to get the full key benefit. Remember the things about agility and innovation and things like that. You got to start thinking about the whole, complete life cycle of how are you going to code, how are you going to build and deploy, and then of course where do you run it and how do you observe it, right? So this is the whole ecosystem that is required for either with ECS or for that matter EKS or any other container orchestration engine, right? So that is the key thing here. That's where of course ECS comes here into picture as a container orchestration engine. It does, of course, where it kind of orchestrates the compute network storage, a lot of these things. But what I'm trying to say is you also got to think about the rest of the stuff. Okay. I think the one thing that I want to kind of tell you from this thing is ECS is the control plane is free to use, right? So we don't charge for that. So I think we only charge for whatever the instances. The workers. The data plane side of things. Where your containers run, whether it's running on Fargate or EC2. So that's where we charge. But and then of course the other peripheral things. If you're using a storage or a load balancer or anything else, we those get charged. But the control plane itself does not get charged. Okay, so that's one quick thing. Now coming to Fargate, so in fact, what has happened is, of course, when we introduce Fargate, which is a serverless compute, sometimes I think it's very natural that people think that Fargate is one more container orchestration platform from AWS. It's not. It's a serverless compute. Right, this serverless compute called AWS Fargate works equally well across both ECS and EKS. Okay, so it's a serverless compute. The biggest advantage with this is you don't have servers to manage, right? So no AMIs to patch, upgrade, or this thing, and of course it's easy to auto scale. And it's not just like you can run Fargate on demand, right? If you're aware of how you run stuff in AWS, the most flexible and also, of course, the most I think the most highest price is the on-demand price, right? Or but if you're willing, if you know that you're going to run them for some time, then we also have something called savings plan where you could give a minimum commitment of a year or 3 years. It comes in a year or 3 years, and then there is also Spot. If you're aware of Spot, which is our excess capacity that we have in our data centers, which we give it to you, but it's better for kind of services which are more stateless and which can't tolerate interruptions and things like that. But bottom line is, Fargate is kind of becoming the first thing that you kind of think about, not an afterthought. Look at, my guidance here would be like, if you are, going by, look at Fargate first. Only if you think it's not suitable there, then you look at maybe an EC2 or some other option, right? So this is, the control plane, and then there is Fargate or EC2 where your containers run, right? And some of the basic things are, the lowest. If you are from the Kubernetes world, you might have heard the term pod, right? Kubernetes pod. So a task is like a pod where it can run one or more of your containers in a task, right? So that is what it is. And this task, you'll have to run it. You'll have to select whether you want to run it on EC2 or Fargate or EC2 Spot or Fargate, right? That's where this task will run. And obviously these all run in the same namespace. They can talk to each other and things like that, right? So basically there will be one application container and a bunch of other things, what we typically call as sidecars. It could be like a caching, it could be a kind of an agent, for example, to monitor your stuff, something like a Datadog or other things, or it could be a logging agent, things like that, right? So typically, people just don't run their application; they also run a sidecar along with it, and that constitutes a task. And this task, either you could run it as like an individual thing, or you kind of bunch it together into a service, right? So the beauty of service is, it kind of does things like maintaining the replica count. You could have an auto scaling at a service level. You could have a mechanism for exposing this via a load balancer, either it's an NLB or an ALB or even a classic load balancer, to the outside world, right? And this whole thing runs in a cluster. So this is how an ECS is kind of constructed, right? So similarly, you have on the EKS side, which will come to that, but this is at a high level how you run stuff, your application, right? So you containerize your stuff, create a task definition, and run either as an individual task or as a service, okay, within a cluster. So that's how you run stuff in ECS, right? Pretty much simple. And then of course we also provide other additional things. You can there's a built-in service discovery, how these services talk to each other with an AWS service called Cloud Map, which which runs on top of Route 53. So you could have something like a private namespace. So you could have two services, service A and service B. They could talk, via Cloud Map, right? And then of course the load balancing, as I said, you could use ALB, NLB, and then there's networking. This whole thing runs in a VPC, right? So you could then opt to select whether you want to run it in a private subnet or a public subnet, right? So based on your requirement. And then one new thing that we started off with something called capacity provider. Remember this, I told you that you could have auto scaling at a service level, but then when you run your stuff, obviously you need some underlying infrastructure to run them, right? The underlying infrastructure could be either based on Fargate if it's a serverless, or it could be on EC2 if it's on EC2. But then one of the things that we noticed was when we launched ECS, this instance auto scaling was still based on native, like EC2 based of auto scaling, which was outside ECS. Okay, so what we would see is when your cluster kind of ran out of capacity, and then this EC2 auto scaling would kick in, and by the time you would have more instances here, this would not obviously match here, right? So this is an entity that was outside, whereas this whole thing is ECS. Now, what we did with capacity provider was, one, we are now controlling this auto scaling via natively via ECS, and we also are giving you a flexibility of having multiple capacity providers with different kinds of things, right? For example, I could have a capacity provider which has a mix of Fargate and Fargate Spot. Okay, so where I could have a policy saying that for my quiescent or my static kind of requirements, always have two on-demand Fargate tasks, and anything which beyond this capacity, always launch it in Fargate Spot, right? So you have getting the best of both worlds, and it's also most cost optimal. That way, you can have this nice kind of, similarly with EC2 and EC2 Spot, right? So basically what I'm trying to say is capacity provider will give you much more control over how your underlying infrastructure gets launched, okay? So that's a new thing with ECS. Now, obviously, we don't claim to have everything. Remember the first thing that I told you about, you need to have the whole complete pipeline, or not just a container orchestration engine, right? So in this, obviously, we have our own native tools, what we call as CodeStar for some of the things. But we also have partners and also open source product that works equally well across this entire life cycle, right? So whether it's coding, either you want to use GitHub or GitLab or CodeStar, or for build and deploy, and for orchestration, right? And then for observability, right? So we have some native integrations with CloudWatch, Prometheus, and Grafana. But if you also want to use other, and X-Ray, of course, from AWS. But if you want to use other partner products, you're very much welcome to do that. Okay. So that is, I think, one thing. I think, and one more nice thing is, now we also have an integration with console for with ECS. I think this was announced, I think, last month or so. Well received by our customers. Because console obviously is a very popular, service mesh kind of a product, right? So that is, I think, a few things about AWS integration with AWS. And now let's go to our new kid on the block, ECS Anywhere. So this is now generally available for use with customers. So obviously, until now, you had an ability to run your containers across multiple things, right? So regions, of course, outposts. I think sometimes customers have, or maybe you also have, some confusion about what is outposts. These are another kind of mini regions that we have launched, not yet available in India, but it's there in the US and a few other regions in Europe and APJ. The outpost is basically, it's AWS hardware that we run in your data center versus this. What we're coming to cater with ECS Anywhere is your servers that are lying in your data center. With Outpost, it's, you could call it as an extended AWS servers running in your data. You ask for, I want, we ship your rack, you go ahead and do it. You not do it, sorry. You go ahead and plug it into your power and networking thing in your data center. And it's like, you would want to call it as like an extended AZ, right? That's what a Outpost is. But sometimes customers don't want to, buy newer hardware, right? They already have existing servers. How do you leverage them? That's where the Anywhere concept comes. So it's different from the Outpost, right? So basically, if you had a requirement for using your existing, and compliance is, I think, a big deal with some of our customers, right? Let's assume that a scenario that you are having a payment switch that cannot be run on an AWS cloud, right? So it has to be running in your data center. But at the same time, you want to, there are ways to access it, right? Either you could connect to AWS via like a direct connect or a VPN, or maybe there's another option where you want to run an app or a container closer to where the switch or the database is, right? So that could be due to compliance reasons, right? Or similarly, for data gravity and latency, right? You've got to be close to where the data is. You don't want to migrate, or you cannot migrate to the cloud. So in those cases, ECS Anywhere comes into picture. The good thing here is, as I said, the control plane still runs on AWS. I have a picture in the next slide, which will make this more clearer to you. And you only run the tasks on your data on your servers. You use the same tooling, and you can manage it and monitor it from a single pane of glass. So this is how it looks. So this is your data center. Let's assume that you have a couple of servers running here, and this is the ECS control plane or the cluster, right? So essentially, the magic happens is via this SSM agent that you install on the servers. That establishes connectivity back to the control plane here. Once it does that, an ECS agent also gets installed here on your servers. And then once it's recognized as an external instance by the cluster, okay? And that, obviously it checks, whether it's alive and it's able to do that stuff like that. So when you launch a task, you can specify that, I want to launch it in an external entity. And that's how this task will get placed here, right? So, and becomes part of it. So so this is pretty simple. So just for your demo, you could always launch an Ubuntu thing on your Vagrant box in your laptop and test it out. Or people have done it on Raspberry Pis where they have launched ECS tasks. So I think bottom line is, if you're able to establish this connectivity, this is a pretty lightweight SSM agent and ECS agent, and then you're pretty good. Okay. So what happens if the connectivity goes, everything it will still be running. So obviously after some time, you still need to get back to the connectivity. Otherwise, this person will not, this entity will not be able to check the lives, the healthiness of this thing that is running here, right? So pretty simple, straightforward. As with ECS, I think the key thing here is it makes it very, very easy. You don't have to a lot of things. It's very native. If you know how to go around the console, you can easily do it. Deploy this whole thing in a couple of hours. Why a couple of hours? So just an hour, right? To this whole thing to just test it out. And of course, it's integrated with Systems Manager and IAM, all other things. And your logs can go to CloudWatch and stuff like that. So that's what I meant by you could leverage the native AWS services with your stuff that is still running on your servers, right? So quick thing about ECS Anywhere, right? Now roadmap, obviously, as I said, a lot of things are happening with ECS. The fast pace of things that are happening. I think it's a snapshot. Just want to repeat, the slides will be shared with you, and including the recording. We'll try to get it out. But these are things that we did last year, right? Anything that I want to the thing that I also want to kind of highlight here is, we launched an ARM-based processor called Graviton 2. We have a lot of EC2 instances that can, or anything which has a suffix of G means it's a Graviton ARM-based right? So now ECS supports Graviton, right? Capacity provider, I just explained. Native EFS support. A lot of these things, IPv6 support, especially for folks who are using things like IoT and stuff like that. So we have IPv6 support in ECS. And a few other things on both Fargate and observability, right? So a lot of things are happening. Now, this year, again, was kind of busy, right? So what has been released so far? I think the key thing here is we had a lot of requests from customers saying that, okay, you guys are managing the servers fine for Fargate, but I still want to kind of get in there and look at what's happening if something bad happens, right? So rather than giving you an SSH way to do into the containers and the instances which you cannot forget because it's managed by us, we give you something called ECS exec. So you will be able to get into the Fargate task and check out a subset of things, right? So that is, I think, the key thing here. This was announced, I think, a couple of days back. ECS on Windows. Okay, so ECS, I mean, if I do not know, it runs both, works on, I guess, three types of, I would say, operating systems: Linux, Windows, and we also have an AWS container native operating system called Bottle Rocket. Okay, so it runs on all these three operating systems. On Windows, until we do not support VPC mode of running networking, but we now support for VPC. So that means you can get a lot of native VPC features that were not yet available with ECS with Windows, right? So if you have workloads that are like need Windows, like for example, legacy .NET applications, which cannot be yet containerized, then you could definitely look at Windows, right? And what else? Yeah, another nice thing is Fargate comes with an ephemeral storage of around 20 GB. What we also did is we heard from some of you that you're running some larger, not larger, I would say tasks which require more storage, things like machine learning kind of use cases. So the 20 GB was not enough, right? So we have it configurable up to 200 GB. Okay, so for those, I would say, fatter tasks, which requires more storage, now you can allocate up to 200 GB, right? Of course, this comes with a cost. The 20 GB is free, right? So you can provision additional storage at a task, right? And of course, I talked about ECS Anywhere and a few other things, right? So this is until July of this year. More stuff is coming down the year, right? In terms of roadmap, I think what else do I want to kind of highlight? Yeah, the key thing here is ECS still does not have a native EBS support, right? Beyond the ephemeral storage, which kind of disappears. ECS, of course, has built-in support for EFS for persistent storage, but for EBS, it's not there. It's, I mean, this is going to be, it's higher on our risk. Higher on our priority. That's going to come shortly. Native EBS integration. It's been a kind of, I guess, a long pending requests from a lot of our customers. What else? I guess few other things around networking, native service discovery, east-west load balancing, right? Not north-south, east-west. And then, of course, on the Fargate, currently Fargate supports a maximum of 4 vCPU and 30 GB of memory per task. People are asking, can you go beyond 4 vCPU and 30 GB? We are looking into it. That is there in our priority list. Of course, Fargate is currently a Linux-only construct. Folks are asking for whether can I run GPU or Windows or Graviton thing. That is also there in our in our list of to-dos, right? So this is our 2021-2022 roadmap. There is a public GitHub. I would strongly request if any of this is very key to you, go ahead and do a +1 on that public grid map. The link will be shared at the end of the thing, right? Now, of course, there are a bunch of compliances that we support, right? I'm not going to go too much into it, but pretty much for most use cases, whether it's the very highly regulated FSI kind of use cases or healthcare or whatever, right? So you could run equally well. Now, coming to the next one on the mix is Proton, okay? So Proton is a service that we introduced this year. Primarily, it's meant for this use case, right? So essentially, you could have a choice of either running it all as an infrastructure, as a service. I mean, how do you manage your servers, right? So, I mean, the key thing that you are running it in containers, but then management of the applications, right? Especially in enterprises and maybe even companies which have good set of regulations, right? So how do you deal with that? Either you can run them in a highly opinionated way, like a PaaS, or running it in infrastructure, right? But both of them have their pros and cons. Here you have more flexibility, less flexibility, but more productivity. Whereas here you need to do a lot of setup. What we decided was, people were building, these kind of what I would say as platforms, right, for running these things, right? How do you create this whole, I would say, scaffolding, right? So customers, in fact, had some of the larger ones like Capital One, Netflix, and all have kind of shared, this whole thing with how they are doing it, right? So this is becoming more and more kind of an ask from our customers. That's where Proton came into picture. It's supposed to kind of an harmonious way on how the infrastructure people and the development teams work, right? So this is a free service from AWS that will, basically where these folks will come and set up the regulations, the kind of scaffolding that the development teams can use. So they will come here, they'll see a catalog of things, in terms of pre-approved, whatever the VPC structure, what could be spun up and so on and so forth. They'll just see the menu, they'll go select that particular menu and deploy their application, right? So that's what it is. And infrastructure teams will be able to see how their development teams are deploying it, right? So I'll share a screen, console screen later quickly on how this looks. But this is how Proton is meant to be, right? So it's like a self-service interface for developers, so that every time you go and deploy a service on Fargate, you don't have to get approvals from that team, this team. They are based somewhere else. You are based here, or you are based here. They are based somewhere else. It takes all this lead time, right? So with this, you have like a self-service interface for both developers and infrastructure. They also have good visibility. They don't know that you're not gone rogue and deployed something which is not certified, right? So all these things are there. Along with that, you also get a pipeline and things like that, right? So before I go to App Runner, let me quickly kind of come to this, right? So if you look at it, basically, Proton looks something like this, right? The key thing here is they start off with something called an environment template. So currently, we support ECS and Lambda as how you this thing. We have a lot of requests for folks to also to kind of extend this model to EKS and Kubernetes. We are working at it, looking at it in a highly prioritized manner from our Proton development team. But right now, if you have a requirement for deploying stuff on Lambda or ECS, Proton works very well, right? So as I said, it's an application deployment and management platform. It is free for use. We don't charge anything at all for this, right? So basically what happens here is, there are two personas, as I said, right? The infrastructure people and then the developers, right? The infrastructure people will go and create these templates and upload it, right? So infrastructure basically means the VPCs, the subnets, creating all that stuff, right? What is a valid thing, or how much people can, what kind of things. And then of course the service template relates to the service, right? Whether it's a Lambda service or a Fargate service, what is approved, what is not approved, and so on and so forth, right? So once this comes up, then basically the key thing here is people, when developers come here, they can they'll go here and they'll say, I want to create a service. When they click on I want to create a service, they will see, basically from this bouquet, right? So in this case, I've said the only thing this developer can do is, this is an approved service from my company, and it's got all the, approved list of, VPC ranges, what is the kind of Fargate settings that I need to do and all this, right? So he just selects this and goes and configures it, right? So all he or she has to do is just give it some name, establish connectivity to some, his backend repository where his source code is, and goes and spins it. Okay, so there's pretty much bunch of things that are here, and beyond that, there's nothing else, this developer has to do from an infrastructure perspective, right? So when they go and spin it, the service gets launched, right? And the service gets launched. An example of a service running here is this one, right? So I've used that Fargate template. I've launched my service, and it is running here. And the good thing here is everything is versioned. So if somebody goes and creates a newer version of a service template, or you can also, edit it and upgrade it. Okay, so those are some nice things that you have with Proton. So in this case, I've launched my service. It's running here. And obviously behind the scenes it's actually running on ECS Fargate, right? So but it's just that the management of it, how do you launch it and things like that, rather than giving that person access to the Fargate console or the Lambda console, you are redirecting them to come to Proton, and this is the single pane with which they will be able to interact to launch newer stuff, right? So that is the beauty of this Proton, right? I hope you're understanding that, especially people who have different teams, the CIO teams, the security teams, the development teams, all these are like, their own kingdoms, right? They each have their own rules, bureaucratic rules sometimes, but most of the time it is because, they want to protect something. They don't want developers to kind of launch something and get caught and get exposed and things like that. So for those kind of use cases, Proton is fantastic, okay? And the good thing here is now the operators will come, they will at any given point of time, they can see, who is running and what version they are running, right? They can, if, for example, if they are running something which is deprecated, right? So they can update it or delete it, okay? So, and it boom, the developers knowing, they can go ahead and upgrade it to the newer version, right? So that's a nice thing here. What else did I want to show here, right? So yeah, so the nice thing with this is because you are integrating with a source code repository, you also get a pipeline along with it. Okay, so it is running on code pipeline. Uttampriya, I'll come back to your questions. Right now I cannot see both screens. I'll come back to your question. But bottom line is, you have a pipeline here behind the scenes with Proton. So, you get this thing automatically with this, right? So, that's what Proton is at a nutshell, right? So pretty much meets this demand. It's a nice meeting point for these two personas, the environment operators and the developers. Hopefully, there'll be less friction, more agility, and launching approved stuff, right? So that is, I think, at a nutshell. As I said, brace yourself. So I'll be going at a fast pace because of the time and things like that. But I will try to answer questions. I'll remain maybe 5 minutes or 10 minutes after our 12 p.m. to answer some of your questions if you have time. But for now, let me kind of go through some of the this thing, right? Now, coming to App Runner, okay? So App Runner is a brand new service that we launched this year. So I talked to you about ECS, I talked to you about Fargate, and then I talked about Proton. Proton is not a container orchestrator, but it's more like a management or a deployment tool that will help the infrastructure and developers, right? Now, when you launch stuff, right, on containers, it's not just you're doing with this, but you also have to deal with other things, right? Like load balancers, you got to set up auto-scaling, code pipelines, and things like that, right? So, and then of course you have your application and backend servers. So you can do that, but what we're also saying is, as you move from EC2 to Fargate to other things, generally what we're seeing is our customers seem to get more, benefits as they kind of replatform it, right? So otherwise, they don't see that much kind of agility, right? So let's assume that you were from containers, you went to Fargate, and for Fargate, you're still, you're not managing servers, but you're still doing a lot of things around the other aspects that I talked to you about, right? If you want to go to the next level, you could, look at again replatforming it so that you will get more stuff, right? So what our customers said is, see, this, I got to add a caveat that this is not applicable to all kind of workloads, okay? But if you have a workload which is purely HTTP based, right? HTTPS based, and your only goal is I want to get to production faster, and it should be fully managed. I don't have the skills or I don't have the time to do it, right? And it should be built for web scale out of the box, right? So you are thinking that you're going to get hit by a ton of let's assume that you want to launch the next Clubhouse next week, right? Do you want to worry about application functionality, or do you want to worry about infrastructure, right? So if you want to launch the next Clubhouse next week, what we thought was, obviously, we got to make your life easier, right? So we got to kind of compress all these things into something one. That's what App Runner does, right? So it's a highly opinionated service to run your applications at scale, right? So no network servers or containers or orchestration to manage. Deploy directly either from currently Git or directly from a container registry, the ECR, right? So we point to one of these two, and that's it. Boom. We take care of it, everything else from there. And then, of course, you also, a nice thing is it's a request-based pricing, right? So bottom line is, behind the scenes, we manage all these things for you, okay? So as you can see, there are a lot of moving parts here. As I said, if you want to have fine-grained control of all this, then App Runner is not the service for you. But if you, as I said, time is of essence, you don't want to manage a lot of things for you, you don't want to manage a lot of these things by yourself, then App Runner is a pretty good service for you, right? So this is what it does, right? So your development teams come and push it, and then App Runner takes it and deploys it and scales it, right? So it scales based on network requests, right? And it is serverless, and it's pretty latency sensitive, right? So that's, and then of course we give you some limited amount of knobs and whistles. We don't want to again burden you with a lot of things like for what kind of auto scaling you want. You don't have to set up anything. And then of course this is how it looks, right? So App Runner will automatically provision a container, make sure your application sees very low millisecond kind of latency, right? When it sees that your incoming traffic is exceeding the threshold, it automatically adds newer containers, right? And the good thing here is when the traffic reduces, it kind of scales down, right? That's what you want, right? So you don't want to be paying at 8 p.m. and nobody else is using, right? So that's the thing with App Runner. And yeah, so this is what it does, right? So you only, it's not that you don't pay anything here. There is some smaller thing like, for example, memory. We still need to kind of, we have this pattern, right? So it says that cold start kind of a thing, right? So for that, to avoid that, we will maintain a minimum one container kind of a thing. For that, you'll have to pay, but obviously it won't be at this scale, right? So this is pretty much what it does. It also, I mean, the good thing here is, when you deploy a newer version, as I will share in my a short demo that I'll show later of App Runner, it does an automatic blue-green deployment behind the hood, and it rolls back if it feels that, the newer deployment is, if the health check fails and things like that, right? What else? Yeah, I think we pretty much covered most of the things. This is what I meant by scales down to 1 and keeps memory provision to minimize cold start, right? So this is the only part you pay for, when it's not being used, right? You do get, it's not a complete black box. You do get access to logs and metrics via CloudWatch, which you can then push it to other backends, right? The logs look something like this, right? So I will show you an actual, console screen, but it looks something like this, right? Completely via the console. Very easy, and then of course you can integrate it with other providers, right? Third-party providers, if you want. If you're looking at integration with something like Splunk or others, right? Pricing, as I said, it's based on how much you consume, right? And quite some time, obviously. So basically, it's like, as I said, it's an opinionated thing, right? And of course, for basically HTTP-based kind of traffic, right? And it contains a bunch of other things, right? So which is helpful for you. Now let's quickly go and look at my App Runner, right? So App Runner is let's open the screen. So if you go and start with this, right? So if let's assume that I have something running here, I'll show you later. But if you start to do a service, right? So as I said, it supports either getting it from the ECR or from source code, right? So in this case, I've already configured my GitHub repository, to talk to this guy, right? Now, in this case, when I go to GitHub and, you select, whether whatever repository that you want to kind of do, right? And then, it just says, whether what should be the trigger, right? Whether it should be a manual trigger or it should be automatic, right? So you can decide what you want, right? And then, of course, how is the build configuration? Now, one key thing here is, first one, I told you that it's meant only for HTTP kind of traffic. The second one is, currently, the only two runtimes that we support are Python and Node.js. Okay, so we don't support other languages. It's there in our roadmap. But yes, you can do it. And then once you do it, and that's it, right? So there's nothing else, no other stuff is here. Now, within a matter of minutes, a new App Runner service will be launched, right? And the beauty of it is, of course, a load balancer will be attached to it, right? So in this case, I've launched this, right? I will copy this link address so that some of you can hit this URL to just check the interesting thing, right? So here it is. This is how my running web app. I have copy. I'll just also paste the GitHub I'm connected to. So this is actually connected to this guy, right? And this is running here. This is just a simple app which is actually also using DynamoDB. Okay, so it is, I mean, if you look at this, right, so it is actually this demo page now, and if you look at this, I can see some logs that is there, stuff like that, right? The configuration, what it's running on, right? Metrics. You could attach a custom domain to this guy. And now, I mean, I told you that it is integrated with the GitHub. So because I made it as auto deploy, right? If I go here and let's assume that I go and change this index.html, right? So I'll go here. This is a demo from the Meetup with the AWS user group, Kolkata and Kochi. Stay safe, right? I'll go and commit the changes here. and it's committed, right? So if I go back here, pretty much it should very quickly know that, see, it's already detected, there was a change in the source code, and it starts, redeploying that application, right? So, I mean, I can go and look at the activity here, and pretty soon it will start deploying it, the newer version, and it's because it's blue-green, to the end users, obviously they'll still be accessing the older service, and once the newer service comes up pretty soon, I guess, then it will start showing that, right? So that is, I think, pretty much what App Runner is. As you can see, it is meant to be very, very simple, make your life easier, but it is not, I guess, what I call as for all use cases. Okay, so that is what I meant by App Runner. So I would highly encourage you to look at this service. What happened here? Is it already up and running? I won't give too much time. I'll always come back to this because in the interest of time, it will come back, deploy soon. Still deployment, operation in progress, right? So we'll come back after a couple of minutes. So that is App Runner. Let me quickly see. Okay, I think there's just one question. I'll come back to that later. Now, very quickly on GitOps, right? So GitOps is something new, I think, kind of taking up with a lot of the customers. So let's just take a sip of water. Yeah, on GitOps, this is a new paradigm that customers are saying, right? So in the sense that I want to kind of make my code repository as my key thing here, which happens to be my golden source of truth, right? So how do I, GitOps is pretty big in obviously in the Kubernetes world. Can I also use this, right? So they're saying, I can run them on EC2 or Fargate. Now, can I take advantage of this, GitOps model where my Git is my place of truth, where, whether I want to push code or configuration, the rest should be automated, right? So we have heard you. That's where we have released, a couple of services. I just talked about App Runner. Copilot is actually a deployment tool and highly opinionated tool. So which can make this GitOps paradigms, working for you, right? So in the sense that, where if your code and configuration is, with Git, you can create a GitOps model, something like by yourself, or, you could use something like either, Copilot or, App Runner to deploy this thing for you, right? So how does Copilot work? So the Copilot is pretty much an opinionated tool. So you point to your Git where you're running your code and configuration. It just asks you a bunch of questions, whether you want to set up like a backend service or something which is a front end with a load balancer to it, and it goes ahead and deploys it for you. So it's not something like an App Runner or a Fargate or ECS. It's a GitOps based deployment tool. And so basically what happens is, once you have deployed it, if you update the configuration, and then you can update your, basically use Copilot to update the configurations. Okay, so Copilot is how can different. Okay, I'll come back to the question. Maybe I'll answer it. What's the question here? How can we run different microservices use of VTs? Do we need to create different running microservices, different ports? Yeah, so yes, I mean, within a service, generally the guidance here is you create different services based on the functionality. Obviously, a service cannot have mix and match of one is doing something else. A service does identical stuff. So if you have multiple microservices, you run create multiple microservices, and obviously within a service, your task or a container will run on a unique port, right? So the guidance here is, create, if your functionality is different, create different microservices, right? So Let's come to our EKS, right? So EKS is a managed Kubernetes service based on the open source Kubernetes platform. And pretty much a majority of the Kubernetes workloads in the public cloud is actually running on AWS, right? So Kubernetes is based on the open source project. It's not one project, by the way. It's like multiple projects based on things like, for example, if you need to leverage the underlying storage or networking or load balancer or encryption, there are like other smaller projects. So what EKS does is there is some kind of interaction with the underlying cloud provider, right? If you want to provision in EFS, you want to provision in EBS, right? You want to provision a load balancer, there are these smaller projects that AWS has contributed and open sourced in all these sub projects. It's all part of the CNCF Foundation, right? So what you've done is made this life easier for developers and infrastructure people to run a highly managed Kubernetes platform on AWS, right? The key thing here is it is vanilla Kubernetes. It's not a fork or something. So when we constantly, for example, I think yesterday we said, EKS now supports Kubernetes 1.21, right? So we will, obviously when the Kubernetes community releases newer versions, we will test it, qualify it, and then add on support for it, right? So that's one. The second is the important thing is, we support 4 versions at any given point of time. So that means, now that we have announced support for 1.21, we'll support 1.21 Kubernetes, 1.20, 1.19 and 1.18, right? The other versions, we will have some deprecation notice that you will have to come and you'll have to upgrade it, right? So this is a fact of life in Kubernetes, right? So you will have newer versions that will come. Earlier, I think the CNCF body was releasing something like 4 versions of Kubernetes every year, right? Now they said that, okay, so 4 might be too much, let's reduce it to 3, right? So now they will release 3 versions a year, but it will be there, right? Whereas in an ECS, you don't have to worry about, what is this version? There's nothing concept of version at all, right? But in Kubernetes, you got to be mindful of the fact that newer versions come up, and how do you handle upgrades of both the control plane and data plane is an important thing for you to do it. Somebody had a question? I'm hearing the voice. Okay. Yeah. I'm seeing an echo. Let me. Okay. No, Kaushik, I think the way they made expensive, Kubernetes is, I would say, for the fact that, there's so much happening behind the scenes. Can you please mute yourself? I can hear. I think somebody. Yeah. Guys, thank you. Yeah, so I think it's I would say it's not made it expensive. The only expensive thing is the control plane cost, which probably Kaushik was referring to. That again is due to the fact that when we launch Kubernetes, right? So we launch it as a single tenant model. So that means if you as user money, I launch a 5 Kubernetes cluster. I create 5 dedicated single tenant clusters for you. And behind the scenes, what we do is we launch a control plane that is spread across availability zones and things like that, right? So because we will give you an SLA of 99.995% for the control plane. And so yeah, for that, I think there is a control plane cost of $0.5 per hour. But for the kind of SLA and the kind of, so this is an auto scaling control plane. Okay, so that means today if you might be running 50 pods, tomorrow you might be running 5,000 pods, right? So we will auto scale and launch more instances to match that capacity. So even other providers who started off with 0 control plane costs, they have realized that it's not possible. So they've come up and created. So it's a very minuscule thing, but for the kind of SLAs and things that you need, I think that is, I would say, is required. But obviously, as with as we have more customers and more capacity at scale, I'm sure initially when we launched, I think it was the control plane was slightly more, we brought it down because as more and more customers started adopting, right? So that's EKS. So the control plane is running in an AWS VPC, and this runs in your customer VPC, right? So this is a highly scalable control plane, and then this runs in your VPC. There are just like with ECS, we support both running on EC2 as well as with Fargate, Fargate for serverless. And within EC2, we also support something called managed node groups. I highly recommend you, rather than using self-managed node groups for running your worker nodes, look at managed node groups. It's a free thing, but it will help you to do things like setting up scaling, upgrades, and things like auto scaling, and how do you patch these instances, via something called add-ons and stuff like that. It helps you much better, okay, with managed node groups. And it also supports. Earlier there was some limitation that you could not use managed node groups for things like spot instances and custom AMIs. That is no longer the case. There are only, I think, a few caveats. Other than that, I think pretty much managed node groups, if you're using EC2, is the way to go, or using Fargate, right? This is how we have come, after our launch in 2017, where earlier our focus was more on control plane. Now we are going with more focus on the cluster operations and data plane, right? A lot of things that have happened last year. I'm not going to read out a lot of things, including things like, our SLAs, more region support, and this is actually not correct, right? I told you that we now support 1.21. Got to update the slides, and then managed node group support for Graviton and other things, right? 2020, anything more that I kind of missed out? Yeah, so to answer Kaushik's question, we announced a 50% price cut from $0.2 to $0.1 per hour for our control plane costs. In 2021, this is something that we have released till date as of, I think, a couple of days back. Support for 1.2.1. The nice thing about this is now we also, because CNCF has said, they're going to move away from this Docker shim to container D. We have announced support for container D. So if you want to, you can switch over to container D completely within your Kubernetes 1.2.1, right? I think a few other things. I think this was big. I think OpenID Connect support, which was a big ask from our customers. Now EK supports that. So these are, I think, a few things that have happened this year. Now coming to other things, one of the big things apart from the versions or other features that I showed you is this thing that is currently in preview, which is called ECS Anywhere, similar to what ECS Anywhere was, which is basically running a fully supported Kubernetes on your data center, right, on your hardware. So for that, as a precursor to that, we announced something called EKS Distro. It's an open source based Kubernetes that Amazon uses for EKS, right? So it's the same version of Kubernetes that EKS uses. It is essentially open sourced. So obviously we'll give you community support and things like that. But if you want to have a production grade support with the installer and things like that, then I think EKS Anywhere is probably the one to go. But if you just want to use our bits to kind of create your own cluster, this is already available both from us and also from a bunch of partners, where they've made it easier to use EKS distro on your servers, right? So I think a couple of things. Probably, I think somebody already mentioned EMR on EKS. Yes. So one of the things that we realized is customers are using. I mean, that's a revelation both to me and a bunch of people, is they were just using not just for microservices and applications and things like that, but what we saw, the kind of workloads customers were running on EKS, where they were using it for a lot of data processing, machine learning kind of use cases, right? So Kubernetes makes it very well for running these kind of workloads. Okay, so that is, I think, one of the things. And one other thing is, if there is an open source project like Istio or Kubeflow or Knative, it can run equally well on EKS, right? It doesn't mean that it's not supported, right? So open source projects, popular open source projects in the Kubernetes community are being run equally well on AWS, okay? So this is a bunch of native integration that EKS has done with the rest of the AWS services, whether it's on storage, security, or networking, or compute, we have integrated equally well, right? And then this reinvent, we also launched something called EMR on Kubernetes, EMR on EKS, sorry. And essentially this is where you can run your Apache Spark jobs, and then you can decide, whether you want to run this Apache Spark jobs on native EMR, our Elastic MapReduce service, or you can select to run it on EKS, right? Either on EC2 or on Fargate, right? So that is, I think, primarily the use case. So this has been well received by our customers. So in the sense, this becomes a new deployment platform for your Apache Spark jobs and managed by EMR, right? So you get the fantastic advantages of EKS in terms of where you can consolidate both your microservices as well as your analytics workloads on a common Kubernetes platform rather than running in multiple things, right? So this is our you no longer have to provision dedicated servers for running your EMR, right, on EKS, on EC2 and things like that. You can you can run these analytics workloads on a managed platform like EKS, right? So this is a new thing that we launched recently in reInvent. So now you have a choice of running EKS in multiple places. So you have like a self-managed EKS distro, EKS Anywhere, similar to ECS Anywhere, where compliance and latency sensitive kind of use cases could be data centers, FSI. Manufacturing is a big thing, right? I mean, obviously warehouses, probably need to have their own stuff that is running closer there. They might have kind of sporadic connectivity back to the internet. So for those kind of EKS Anywhere is there. And then you also have outposts and local zones, right? And then of course, normally running it on AWS cloud. So these are a few options for you. EKS Anywhere looks like this. So compared to ECS Anywhere, EKS Anywhere is different in the sense what I told you is it's full-fledged control plane and data plane that is running in a servers, right? So essentially, it's the only connectivity you will probably need with ECS is, we will have a single plane of, basically manage plane that you could look at and manage it. But pretty much this will be running independently on your VMs on EKS Anywhere, right? So the integration is only with the EKS console if you need access to those things, right? Otherwise, this is a full-fledged complete EKS cluster running in your data center. Currently in preview, we hope to launch it generally available before the end of this year. This is distro, the open source one. Similar to ECS here, most of the compliances have been done with EKS. Very quickly, similar to ECS, GitOps is one big area for our customers, right? So we have, of course, there are many frameworks for doing GitOps with Kubernetes, whether it's like Argo or, using Flux, right, from vworks. So you could use one of them. I mean, the bottom line is, whether it's, essentially deployments, or application deployments or infrastructure deployments. So you will be using Git as your, basically your central source of truth. And then you can manage your both your clusters as well as your application deployments using Git, right? So that is primarily what GitOps with EKS does for you, right? So that was, I think, pretty much on GitOps. Coming quickly to AppMesh. AppMesh is our service mesh product. I did talk about primarily around using CloudMap for service discovery. But if you need a full-fledged AppMesh, which is managed, right? Then we have AppMesh. So basically, this is meant to address some of your day two problems, right? So basically, you have deployed your clusters. How do these services talk to each other, right? That's the important thing, right? So that is where AppMesh comes into picture, right? So essentially, what AppMesh is, it's a fully managed service mesh. It's free of cost, and it runs. I mean, one of the things is if you need a service mesh where you want to use it not just with EKS, but you also want to use it with ECS or even Fargate or services running on EC2 or just any other applications running on EC2, AppMesh works for you, right? So essentially, it has a bunch of features. I'm not going to go too deep into it, but bottom line is, the AppMesh architecture looks like this. So we have an open source Envoy sidecar container that will be running along with your application, either in a task or a pod, right? And this will be managed by the app mesh control plane, okay? And these, we, as I said, app mesh works equally well for your containers or your applications running on EC2, right? Or ECS, EKS, Fargate, or self-managed Kubernetes also. And it is integrated with, for example, you just want to not just shift the traffic, you also want to kind of also understand how much time is being spent and things like that. So typically you will also use app mesh with X-ray, right? So bottom line is, it's a very small footprint Envoy sidecar that runs along with your application, and then it intercepts the traffic between these two containers, and it goes via this Envoy, right? And it supports a bunch of protocols, whether it's HTTP, HTTP2, gRPC, or TCP, right? So the architecture for app mesh with ECS looks something like this, right? So the Envoy works along with the sidecar, and metrics get pushed to CloudWatch where you can observe it. And then using the app mesh control plane, you can do all these things like shifting traffic. You want to do things like what is it, blue-green deployments. You want to do things like circuit breaker and stuff like that, can all be done with app mesh. Similarly, the architecture with EKS looks something like this, similar to what we had here. Same thing running as a sidecar, right? So app mesh is kind of an underrated service, but as I said, this is a native service mesh free of cost from you. If you feel that if it helps you in some of those day 2 problems, right, then I think you can definitely look at using a app mesh for your thing, right? So there are a bunch of examples where we have shown integrations with some of these services, right? Now let me come to the last part of my session, is on the fundamental question on which service is good for you, right? See, the thing is, ultimately, we give you choices. These are our native services. We have no bias against each service. Ultimately, based on your use case and your workload that you're trying to deploy, and what are your strengths in terms of a team, right? And then what is your business drivers? Based on that, you kind of decide it, right? Now very quickly, the mapping between Kubernetes and ECS, right? So I told you about this is called a pod in the Kubernetes world. A service is a service, but it kind of encapsulates much more than what it is. So on the Kubernetes side, these are some terms that we use, right? Namespace is something very unique in Kubernetes. The equivalent we probably is a cluster. We don't have something like a namespace in cluster in ECS, right? So these are, I think, from a terminology perspective. But let's assume that you have a new to containers, but are very familiar with AWS the way of thinking, right? As I said, my customers that I talked to you about, very familiar. They're using EC2 already and things like that, but they want to run stuff, right? And so in that case, I would say, if you don't, if that is your only thing, you want to run something at scale very quickly, and using whatever the AWS native way, so then probably an ECS is a good fit for you, right? That is, I think, what I would say. But if you want, if you have a company that's saying that I want to use open source, I already have good Kubernetes skill, either I'm already have a self-managed Kubernetes either on AWS or some other platform, I want to leverage that point, then definitely EKS is a good place for you, right? So it's fully managed, a control plane SLA of 99.95%, a choice of running your containers on Fargate or ARM-based processors or Bottle Rocket, right? That is, I think, EKS is a fantastic. We have a lot of customers using this, right? So EKS, probably for some of these specific reasons, it might be a good. And then, of course, we also, as I told you, Kubernetes is not just one project, right? There are multiple ecosystems, right? So EKS also gives you something called managed add-ons. So if you want to upgrade a networking driver or a storage driver or like a kube proxy kind of a thing, right? Or core DNS, we also give something called managed add-ons that can be used to upgrade these other projects, right? So EKS and ECS, I think, pretty much I think these are the decision points. But we also have, I think I mentioned it very briefly, is we have something called ROSA or a Red Hat OpenShift managed on OpenShift. So if you have already invested in OpenShift and but your goal is more to have a managed OpenShift offering on AWS, then ROSA is an offering from AWS for you, right? So coming to a bit of nitty-gritties, this is how it looks, right? So you have Amazon EKS and ECS, and below that you have a choice of multiple choices. I'll quickly drill down to each of this. So you have to go through these decision points. Okay, the first thing is in terms of purchasing, right? How do you want to pay for it, right? So do you want to pay for on-demand price, or you think that you're going to run it for at least for a year or 3 years, right? So then go in for savings plan, or you say that mine is a stateless workloads, I want to just pay for the cheapest option, right? So then Spot could be one. So you can select one of the 3 ways to do it, right? In terms of purchasing. And then the next question is, this primarily from a Kubernetes perspective, I have a requirement to run daemon sets, right? Or I want to run something as sidecars, right? Or there is also an option to run something called a sidecar where we manage the sidecar for you. Things like the logging router, right, or the storage driver. Then the choice becomes based on this, right? For example, I'll come to which one will be a good set. Then the second one is, where do you run your containers, right? I want to run them in a AWS region or a local zone or outpost or my data center, right? So this is one more decision point, right? And finally, what kind of CPU architectures I want. I want to run it on x86 or GPU or ARM, right? GPU is very important because, as I told you, a lot of our customers use ML-based kind of workloads, right? So and then, of course, the operating system. I want to run it on Linux or Bottle Rocket, which is our AWS Cloud Native operating system, or Windows, right? So, and then finally, x86, GPU, or ARM, right? So this is basically the decision points, right? The purchasing options, whether you want to run this, where do you want to run it, the operating system, and the processor architecture. So these are, I think, finally, more analytical way of doing stuff, right? Where do you want to run it, right? I just told you about ECS and EKS, but then within ECS and EKS, where do you want to run it, right? Whether you want to run it on EC2 or Windows or Linux or Fargate, right? So once you have these decision points, then let's assume that for this combination, then EKS with EC2 will make sense. Okay, so x86, GPU, all these things are supported. Okay, daemon sets, sidecars, and things like that. Okay, but if you want to use EKS with Fargate, the key difference here is, you see there's some of those things, right? Daemon sets and things like that, GPU, ARM, and all those things. But if you want to use with EKS with Fargate, and you don't need things like daemon sets, you don't need GPU, you don't need what else was there? ARM-based instances, then EKS with Fargate makes sense. Okay, so this is one thing, right? EKS with EC2, EKS with Fargate. Now, similarly with ECS, same thing, right? You want to use all these things, then EC2 would be probably a good choice. If you don't want to use it, so this is coming. Okay, it's not it there. I think there's a small mistake here. It is coming, not it. So currently it's only Linux. So Linux, x86, sidecars, and these things, then Fargate is a good choice for you. Okay, so that is how it is, right? Very simple. I hope I made it very clear in terms of how to go about it in a more structured and a scientific manner, right? Rather than doing something and missing out, I think use this kind of a mind map to do it. Good. Coming to the last part of my slides, now you got all these things about ECS, EKS, App Runner, Proton, and other things, right? Now, how do I go about it, right? The first thing, piece of advice that we will tell you is, of course, you need to do a discovery, right? So you need to look at a few things and what you have, right? Sometimes I have customers who have just runtime, they don't have code, right? So in that case, it becomes very difficult. But these are a few things that you need to make as a checklist on your current state of application, especially for, I'm not talking about cloud native applications, right? So that means applications that have been written with containers in mind or Lambda in mind or something else. These are existing applications. How do I modernize them? So these are some important data points that you have to collect. It does not mean that you need to know everything, but I'm saying these are important points. And now once you have this, this again kind of makes it a little easier for you, right? As long as it is modern programming languages, few other things, it's fairly easy. Okay, this is you need a bit more work and things like that. And most difficult is non-x86. Probably you could reuse some bits and pieces of the business logic, but pretty much you'll have to rewrite a lot of these things. Okay, so modernization from existing legacy applications becomes from easy to difficult with this kind of a thing. And then you take a call, how do I now modernize it, right? So as AWS, we have some tools and utilities. The key ones are, top two key ones are, we have something called App to Container. Both are free. I think they're also open source now. This will look at your both Windows and Linux applications and help you migrate some of them applications, right? But then the caveat is obviously these are tools. Sometimes they might not be the most optimal one. So I would just suggest, whatever artifacts that they produce, review them and optimize them. And similarly, the .NET Assistant essentially helps you to scan your code and look at what aspects of .NET you're using, right? It also helps you to migrate from .NET to .NET Core, right? Because then the moment, I hope you understand that .NET Core, with .NET Core, then you have a choice. Of course, in terms of performance and roadmap, that is the future. Apart from that, once you are in .NET Core, then you also have a choice of multiple operating system. You can run them either on Linux or Windows, right? Versus a .NET, which could probably only run on Windows. So again, those are, you could use one of this from an application side. And from database, of course, we have a bunch of other tools. This is a replatforming assistant. If you're not yet aware, Microsoft SQL Server is now available on Linux also. So just moving your database from, say, Windows to Linux itself, you'll get a lot of cost reduction. And we also have something called Babelfish that will also help you to move some of your SQL workload to other open source based operating system, right? So replatforming assistant will help you to move your SQL Server from Windows to Linux. Schema conversion tool and DMS are more for scanning your database and either doing a like-to-like migration or like-to heterogeneous kind of migration, right? Oracle to something else, SQL Server to something else. So all those things will do. Again, these are more, you cannot just rely on the tools, right? So you got to do first get a report, and then look at the report, the compatibility, and then look at how much can be automated, how much needs to be manual, right? So just to recap, app to container, porting assistant, and then from the database side, these things. So all these things will definitely help you in this journey of modernization, right? So I think I just come to my kind of a marathon session covering everything. Before I open up for a look at the questions and things like that, a couple of things. First is, of course, our roadmap is available out there. As I said, things like, from other features that I was talking to you about, the upcoming features. If you feel that you're going to benefit from them, please do, go to the roadmap and do a +1 or ask for more information, right? Or if there's a feature which does not even exist, you can create a new issue there and our product management team will have a look at it, right? And then others also can probably vote for it. That's one. The second one is, I posted the slides. The link will expire on 30th July, so you can use them to, download the slides and things like that. I'll just gonna keep this for a minute here. Okay.